Hydrogenation and hydrogenolysis are widely used techniques, for example in the conversion of olefins and acetylenes to their saturated compounds, conversion of a variety of nitrogen functionalities to amines, and the removal of benzyl-based protecting groups. The technique is straightforward and usually performed under mild conditions, and the workup is very simple, consisting of filtration of the catalyst and evaporation of the filtrate, often leaving pure product for further processing. However, care is needed in the filtration of hydrogenation catalysts due to their pyrophoric nature and the almost universal use of flammable solvents in the reaction if fires are to be avoided. The risk of fire in the filtration of catalysts is unpredictable, as some catalyst-solvent mixtures are worse than others, with palladium on carbon in methanol being very susceptible to ignition. Therefore it's best to err on the side of caution with all catalysts. Two widely used methods are available for catalyst filtration: suction filtration into a Buchner flask, illustrated here, and pressure filtration using a chromatography column and nitrogen pressure, this latter being particularly suited to the filtration of Raney-Nickel reactions. A simple setup for suction filtration is shown here. The flask is firmly clamped to prevent it tipping over, and the Buchner funnel is ready, containing a layer of Arbocell as a filter agent. Arbocell, being a combustible support, allows the catalyst to be recovered and sent for recycling. The conical funnel connected to the house nitrogen supply allows a blanket of nitrogen to be created around the filter funnel, and it's this feature that ensures the safety of the whole process. It's a good idea to have a wash bottle to hand of the solvent in which the reaction has been done for rinsing the hydrogenation vessel, and also one of water for immediate damping down of the catalyst when the filtration is complete. First, remove the magnetic stirrer from the reaction vessel. Rinse it and put it on one side. Start the suction in the flask and turn on the nitrogen to create the inert blanket. Carefully start pouring the reaction mixture onto the filter pad at a rate to ensure it is covered with liquid all the time. The filtration is not usually very rapid, so the rate of addition is fairly easily controlled. Gentle swirling of the vessel before each addition to the funnel will help to ensure that the catalyst stays in suspension and is captured on the filter pad and not left at the bottom of the vessel. When the vessel is empty, rinse it with some solvent to remove the last few traces of catalyst, and then put on one side. Allow the solvent level in the funnel to get close to the top of the filter pad, and then rinse with a little more solvent. As soon as the filter pad is exposed, damp the catalyst with the water wash bottle and turn off the suction. The filtration is now complete, and the bulk of the catalyst may be placed in a labelled waste catalyst bottle, again damping it down with water. The filtrate may now be evaporated and the residue processed further.